The second technical session is on the topic of climate changes on decadal to sub-millennial time scale. And may I request Chairpersons Dr. Rasik Ravindra and Dr. Rajiv Nigan sir to kindly come and occupy the stage. I think the whole house is eager to listen from both of them, and we have got two wonderful keynote addresses. First from Dr. Rasik Ravindra sir, if you are ready, then we can start with it right away. Vanishing Arctic sea ice and its global implications.
Ladies and gentlemen, if you are ready, I can start. So I take you to the two polar regions, and both are poles apart, as we generally say, one in the north and one in the south. I will not be touching Antarctic, though that's the area of my more interest. But currently I will be speaking on the vanishing sea ice in Arctic, because as you know, the current models that people have been working upon, they are predicting that by 2040 and 2050, the entire Arctic Ocean will be ice-free. And the implication of that ice-free Arctic Ocean are scary, are going to be disastrous, if I can use that word, for our Earth system. I have divided my talk in this format. We'll try to understand the Arctic. Then we'll try to see what are the vanishing sea ice scenario. And we'll also look at the causes, why this ice is going out of the Arctic. And then what are the consequences of this phenomena. And in those phenomena, we'll see the impact on environment, impact on the Indian summer monsoon, the birth of the new navigational routes that will be opened because of the diminishing sea ice, and then impact on the resource exploitation and on the health of the people, those who live there. If you look at the geography and the demography of the Arctic and Antarctic, the Antarctic down below, if you look at that slide, you see a huge continent of the size of 12 million square kilometer, but there's no permanent habitation, there's no population, there's no government. This particular area is government free. There is no sovereign control of any nation on that. Compared to that, the Arctic is surrounded by the land mass, but this is an ocean as contrast to the continent of Antarctic. Now this Arctic Ocean basically has got the Canadian government's role, the Greenland, the Iceland, here the Norway, and then the Russian Arctic. Now these states are called as the Arctic states. There's a council, Arctic State Council, that runs basically the Arctic Ocean, and it is responsible for the environment of the Arctic Ocean. So that's the basic difference between the Antarctic and the Arctic. And if you see over this, the same thing that I was trying to tell you, there's a indigenous population which lives in the surrounding areas of the Arctic, the Russia, and these figures are of the indigenous people, indigenous tribes that live in the Arctic area. And it's a huge component of that, you can see over this. That means the Indian connection with the Arctic is very old. It goes back to nearly 1920, when India had a treaty with the Svalbard. It's called as Svalbard Treaty, which gave us some rights to work in that area, even to exploit the resources in the Arctic. Of course, we never utilized the provisions of that treaty till 2007, when we started our own expeditions to Arctic, and we established in a small Arctic station of India in And this is the Indian station Himadri, which is in the Arctic. You can see over here. This was inaugurated in 2007. And then these are some of the glaciers which we work upon. One of the fields of our investigation in the Arctic, though we have got several other investigations doing upon. Now coming basically to the topic of this seminar is why the current scenario of the global warming is felt more severely in the Arctic. And as you see, the Arctic is warming twice as fast as the other part of the world. And this warming is very severe if you see the past history of 3 million years, which is available to us through different ice cores. Each of the last 4 decades, if we start from 1980 onwards, has been more severe. And I think this part was touched upon by some of my previous speakers also. If you take 1850 and 1900 as the baseline of the temperature, from that 50 years scenario, the current century or the decade 2001 to 2020 has seen the warming of 0.9 degrees Celsius. And if you see the last decade, just the decade before, that is 2011 to 2020, the rise has been 1.09 degrees steeper than our 1850 to 1900 scale. Now these 2 figures or 2 slides are basically drawn from the IPCC record, and that IPCC's report of 2022, and it shows very clearly that the rising temperatures and declining Arctic sea ice have got a direct relationship, or you can say the inverse relationship. As the temperatures go up, the Arctic sea ice goes down. And you can see the one slide on the right is just a mirror reflection of the other. And this steep rise was also shown by our chief guest over here, where the steep rise in the temperature from 2000 to 2020 is very conspicuous when you see this temperature rise from 1850 to say 1950 or 1970 also. And in this slide, what IPCC has done, they have differentiated the observed rise, the simulated rise, when you take the natural component, and also the simulated natural only, that means without the anthropogenic reasons. And you can see these 3 different curves on the left hand side, which are very clear. Now this is only simulated natural only, taking into account only solar and the volcanic part, whereas this is the observed one, the black one, and then you have a light brown graph which has simulated human and natural. So apart from the natural variability of this phenomena, we have a great component of the anthropogenic reasons, that means the natural, the component of man-made activities. And the slide on the right hand side, it takes you right up to the March 2023 data. Of course, the maximum depletion comes in September, because September is the time when the total ablation is measured in the Arctic. But the figures till now are available only up to March 2023, and you can see this fall, or the gradient of the fall, is still steeper. And by the end of the March 2023, the IPCC report says that 600,000 square kilometers of ice from the Arctic Sea has been lost. Now this is a very interesting cartoon. If you try to see from the left hand side and go on the right hand side, you can see that in the 1985, the entire Arctic Ocean was covered by this sea ice. Only at the border of some of the areas of the Alaskan area or here in the Greenland side, there were some greener portion or blue portions that reflected the sea ice free Arctic. But when you come down to 2002 over here, you can see huge patches of blue sea getting reflected here, and the ice has, snow or the sea ice has got concentrated only in the central part. And this is gradually leading to this scenario, because infusion of fresh water and the snow sets up a site of a gyre, and this is called Beaufort Gyre. This pushes the Arctic sea ice from the Greenland side onto this fjord, and then this particular sea ice goes down and it enters the main ocean, leaving the Arctic Ocean. So practically, if you see this line here, this is the average of the line between 1981 and 2010. The average of the spread of the sea ice, and current is over here. So this much of the sea ice has been lost. And this loss is going on, it has not stopped, it's going on. So some of the statements, which are very, very scary, I'll just read it for your benefit. In one of the warmest decade, that means the last decade, 2011 to 2020, annual average Arctic sea ice area reached its lowest since last more than 100 years, since 1850. The Arctic sea ice is shell of its former self. The orange line that I was telling you shows the typical sea ice extent for the mid-September between 1981 and 2010. And the IPCC recent report of 2021 says that the summer Arctic sea ice may disappear totally by the middle of the century if the greenhouse gas emission is not stopped. And you see on the right-hand side, all the Arctic sea ice is young. That means it is only very recent ice. Now there is a difference between the multi-year ice and the fresh ice. If the ice is more than 2 or 3 years old, it is stable. It doesn't get very quickly taken away. But if the ice is fresh, then even small change in the temperature will take it away. And that is very scary because then the entire ice will become taken off. And it is said that only 1.2% of the ice that is left now is a part of the multi-year ice. All others is gone. These again here are some of the pictures which are taken from the Norwegian Polar Research Institute, which are our partner in the research when we are collaborating in the National Center for Polar and Ocean Research in Goa. The first figure is a picture. It is not a cartoon, it's the actual picture taken in 1939 by a gentleman who is sitting on this rock. And you just visualize a small mountain over here, the glacier, the completely frozen sea, and then you come to 2010. The entire ice over here has gone. Now you see only the sea. The mountain has been exposed, and the entire area of where the sea used to be there is now available to you. The rock portion of this remains at the same spot. Look at another scenario. This is a huge frontal part of a glacier, which is basically called the tongue of the glacier. This tongue is so tall, more than 150 to 200 meters, that it is camouflaging the mountain peak over here. But now, you can see the mountain peak and this entire tongue is gone. This we have seen in our own lifetime, which is very, very difficult. Because what nature has taken thousands of years to build, our activity, anthropogenic activity, has reduced it to a couple of years. Here you can see the direct relationship between the increase of the CO2 and the decrease of the sea ice. As you go on increasing carbon dioxide emission, say from 0 to 300 ppm, you can see the loss in the sea ice that is taking place. And this most difficult part or unfortunate part is that internal variability is responsible only for 40 to 50%. So rest of the damage is being done by the man-made activities. We are adding roughly 40 billion metric tons of carbon dioxide pollution to the atmosphere, says the National Ocean and Atmospheric Survey of the US. And what is the impact of that on the ocean? The oceans are warming up. As I said in the morning, the upper ocean stratification is getting disturbed because ocean water has got a stratification, the denser water and the lighter water, and there is a horizontal stratification. Now, because of the increased amount of the carbon dioxide, the ocean becomes more acidic. The stratification gets disturbed, and the ocean becomes deoxygenated. And when these things happen, the entire thermohaline circulation of the ocean gets disturbed. Now, by thermohaline circulation, I mean that the deeper water, the denser water goes down, the lighter water, the warmer water comes up. And this is a circulation which takes place in the ocean. When this circulation is disturbed, the entire system of the nature, the entire atmosphere, ocean, land coupled system gets disturbed. And it has got ramification on the rainfalls, on the atmospheric system, because atmosphere doesn't have borders like China, India, US. Atmosphere is one, like ocean is one. Between 1900 and 1990, sea level rose between 1.2 mm to 1.7 mm per year. And this increase is going to be 3.2 mm by 2016, it was. Sea level is expected to rise even much more rapidly. And all these changes are irreversible. That is the most unfortunate things. This is a vicious circle, when you remove the snow, sea ice from the Arctic, what happens? The blue water of the sea becomes exposed to the sun. And this blue water, which is ice-free, absorbs the radiation. So the albedo effect is there. That means there is no ice which can reflect back the sun rays, which can reflect back the heat of the sun. So the entire radiation, the entire heat process is absorbed by the water, which is ice-free, and this sets in the global warming or the Arctic amplification that we call. Now, there are two basic laboratories, one in the Scripps Oceanography and another is located where we are working in the Nielsen in the Arctic. And you see both of these laboratories have measured the CO2 percentage of nearly 417 over here. Yeah, 417 ppm over here. And also in the Nielsen, it was measured as 419 ppm in 2021. So this has never happened in our past. The maximum percentage that we have seen in our memory, the observational memory was 300 ppm. In the last 800,000 years, this figure of 419 or 420 ppm was never reached. You see over here, 800,000 years before, and you see up here is 0. This level of CO2 has never gone above 300 ppm. But now in 2023, we have already reached 419 ppm. Nigam sir, please tell me when time is over. Now, what are the consequences of this ice-free Arctic? We will go quickly over this. Okay, fine. There are a couple of bullet points that we have taken from the IPCC reports and from the NOAA, also from the National Snow and Ice Data Center of US. I'll read it quickly for you. The sea ice plays an important role in the climate system in that it influences the ocean to atmosphere fluxes, surface albedo, and ocean buoyancy. I have already explained to you what the albedo is. Significant warming of the Arctic will occur during the 21st century. Mean increase between 1.6 to 3.9 degrees Celsius, and majority of this will be seen over the oceans. Alteration in the atmospheric circulation and precipitation patterns will be more widespread, extending down to the mid-latitude storm tracks. That is why we are experiencing more of the storms, more of the extreme events, which was not so frequent. The frequency has increased recently, as most of us have observed. The sea ice-free Arctic will have serious impacts on the monsoon and result in further increase in the extreme events. We will see this in some more detail because the Indian government or Indian researchers are working a lot on this aspect. It directly impacts us. The increased shipping routes, shipping due to the sea ice-free Arctic could have a considerable impact on the local ecosystem, for instance, through toxic discharges of the pollutants, and the fragile habitat will be disturbed. Increase or overfishing may wipe out certain species of the fishes which are very typical to the cold water species. Now let us deliberate upon the impact on the monsoon. It is called as telecommunication. The impact of Arctic or Antarctic on the monsoon. The Antarctic is still being worked upon, but that Arctic has got very serious impact upon the monsoon has been established by the researchers, not only from India, there are other researchers from China and US also who have worked on this aspect. There are two papers which have recently been brought out in 2004 and 2003, and the references is there. And these say that the teleconnection between the Arctic sea ice coupled system and the Indian monsoon has been established. The natural climate variability in the polar regions such as Arctic amplification, North Antarctic oscillation, and SAM, or the Southern Hemisphere annular mode, together with the rising SST, can impact the Indian monsoon through the teleconnections. And these teleconnections are nothing but the various atmospheric phenomena which Arctic impounds on to the mid-latitudes, that is the Indian part. The records show that the strength of the Indian Ocean summer monsoon had abrupt variations during last 12,000 years. Now this is established by several workers. In every case, when the ice rafted debris events in the North Atlantic occurred, the summer monsoon strength decreased correspondingly. That means whenever you had these ice movements in the mid-Atlantic, you could see that the summer monsoons were not at the same level. It has also been shown that the Arctic ice melting and decline of the sea ice would result in reorganization of the ocean thermohaline circulation, which will lead to change in the temperature and the moisture gradient over the southern subtropical Indian Ocean, and eventually it will control the Indian Ocean. Our own institute in Goa, NCPOR, has constructed a multivariant sedimentary record covering a period between 1106 and 1967 using carbon and nitrogen isotopes from the organic matter which was derived from a core in one of the Arctic fjord. We have a Arctic station, as you know, and there is a fjord very close to that, and these cores have been retrieved from there. They identified warm and cold Arctic spells at multi-decadal resolution during the last millennium, and these interchanging warm and cold episodes were linked to stronger and weaker monsoons over India respectively. And these are the two papers which have come up recently in 2021, and the other one is in 2023. But this is not that only the Indian monsoons are getting affected, even the Arctic is getting affected. When we have serious monsoons or very severe rains, as we had in 2010 in Pakistan, there was a strong Arctic jet which was found in the Arctic nations, and they suffered huge cold spell in the entire Arctic. So this is a mutual, when once we have more monsoons here, rapid monsoons, even the Arctic has got a variation because the entire hot jet moves towards the Arctic. There will be some more impacts, for example, the permafrost. Now these are the regions of the permafrost of the Arctic, and as you see that 85% of the land in the Arctic, in Alaska, Canada, Greenland, Siberia, they are all covered by the permafrost, and most of these permafrost will be lost. Every additional 1 degree centigrade warming has an additional 1.5 million square miles of permafrost depletion. It takes place. Now, once the permafrost goes away, you will find the thawing of the permafrost, the rock slopes, moraine and debris covered areas, they become unstable, vulnerable to erosion, they destroy homes, bridges, roads, as you can see over here, glacial lake outburst, and most of all the people, those who live in this Arctic area, as I showed you, there are a lot of indigenous people who live in these states, they get affected. The methane gets released, which is again a very dangerous situation, because large quantities of methane, when they are released to the atmosphere, they have its own impact. Pathogens can get released. Natural mercury can get released. And some of the diseases which were outbreak of, for example, in the Siberia we had outbreak of anthrax. Now all those carcasses or the bodies which were buried in a mass grave, when the permafrost goes away, what will happen? All these microbes, all these pathogens will be released, and then what will happen to the mankind is a big question. Mineral resources, all these oil resources which are presently known in the Arctic, these are the confirmed resources, these are the probable resources, and you can see over here 18% of the undiscovered oil, 30% of the undiscovered natural gas is still in the Arctic. Apart from the oil, we have zinc, gold, iron, nickel in Russia. All these resources are available, and once this Arctic is ice-free, these all resources will become available to mankind. For example, Russian in the Yamala Peninsula, they have already started taking out the gas, and China has got huge investment in these areas, and they are directly shifting this gas to their parts of the China. 30 trillion cubic meter gas is enough to supply wood for a decade. So all these resources become available to you, and two routes, the north-western passage and the north-south passage, it becomes available. It will save 40% of the travel time. It will be 40% faster. So the entire world is looking after these two routes which will become available. But then what happens to the atmosphere? What happens to the environment? This happens. People will lose their habitat. They have no place to go. Thank you. Thank you.
This is the beauty of experienced presenter, exactly 20 minutes, sir. Thank you, sir. Any query with Professor Rasik Ravindra sir? If no, then I will go ahead.
Sir, how much estimate? Sir, just one. I am enthusiastic to just one question. Sir, this much ice water is melting. Okay, ice is melting. Sir, how much land will be occupied by this sea melt along the continental margins that are existing along the Arctic Sea?
See, if you have a glass, put ice cubes in that. When the ice melts, what happens? The water doesn't go out. Because that ice cube has already occupied some space in the glass. So similarly, the sea ice is already having some space in the sea. Sea ice melting will not cause the global rise of the sea level, but the land ice, if it melts, that will have impact. So this sea ice melting will have impact on the atmosphere, on the geochemistry of the ocean, on the water quality, but not on the sea level. But if the land ice melts, yes, that will be dangerous.
Most of them starting with Norway, Sweden also to some extent, Finland also, Finland is very much. So they have moved over to this renewable sources of energy. Means their energy is about say 90-95%, in some cases 99% it is renewable energy. So if the pollution is less in Scandinavian countries, does it affect the Arctic ice? Or suppose some US is releasing lot of greenhouse gases. So does that means if the neighboring countries are not releasing, so does that have any positive impact on the Arctic this melting?
Look, as I said, the Arctic Council nations, all these countries are the Arctic nation, Arctic Council countries, and India has also got a status of observer. Though we are not an Arctic country, but we have got a status of the observer in the Arctic Council, and basically that is because of our work in the Arctic. And one of the work is relates to what question you have asked. Whatever pollution the Arctic sea ice is facing, that is not absolutely or 100% because of the polluted material created by these countries. Because atmosphere knows no bound, no boundary, no border. So the pollutants, the aerosols, they can come from anywhere. So 100% pollutants are not from these states. The pollutants can be from anywhere.
Sir, can I take up one question, please?
Yes, most welcome. If he allows.
It's a query rather than a question. Like we all knew, like in ATCM in 2006 and 7, when you were heading the Indian delegates, and like all our learned viewers, listeners, sir fought too well and got like against the wishes of Australia and other countries. India got the permission to build the second Antarctic station in Bharati. And that's a thing sir actually is known for, like he brought the second station. Sir, the ATCM again is going to be held next year in Kochi.
Yeah.
So any agenda like that which India is going to like pursue?
Well, it's a historical event for India because none of the country has got a privilege of hosting ATCM in such a short time. After 2007, this is only 2002-04. And within these 16 or 17 years, we have got this privilege. It's a big event for India. And we do have certain agenda. First of all, we are going to replenish or rebuild our 30 or 40 years old station, Maitri. And you know, whenever we take such a huge construction in Antarctic, we have to do a huge comprehensive environmental evaluation report. And we are already working on that. And we do hope that we'll be presenting to the ATCM our proposal of building a new station at the same place in Shimaka, where our Maitri was there. And second is that on the agenda is the climate change. Every ATCM subsequent to 2010 has been having an agenda on climate change and tourism. So these two issues will again be on the topmost list of our own ATCM.
Give Professor Ravindra a big hand. Yes. And he will be around here, so if there are more questions, he will be available. You can put that for it. See, we all are worried about perspective of climate change. Every second conference is on the climate change. And in today's presentations also, if I start with the Honorable Chief Guest, she talked about the Milankovitch cycle, the climate. The Raju or Rasik Ravindra Saab has talked about likelihood in the sea level rise. I will take you to the journey in the past. Whether sea level has gone up or down in the past? If so, what happened then? Because that will guide us what will happen in the future as well. And I will take you more towards the methodology, the tool, which can help you to get an idea how climate has fluctuated in the past. Why to study past? That's a big question. As a student of geology, we all knew present is key to the past, and when we put present and past together, we get an idea about the future. So I will talk more about the tool which can help you to get the environment of present, past, and the future. So the issues related with the past climate, which helps to get an idea about the future, I put it under the heading, the paleoclimate and the issues which is related to the modern environment, which is also a big problem. Not only the atmospheric pollution, even the continental pollution or the marine pollution also is becoming a cause to concern. So I will be talking about why to study paleoclimate, how to study, and is it possible to predict the climate. And same is with the pollution. Since I put a lot of slides, so I would like to hurry up, but you can put a question if anywhere I'm not clear. Morning when you open the newspaper, you get an idea about this. Since this morning, we are talking all about global warming. And this is my very favorite slide. About 23 or 25, year 2000, I addressed the issue of global warming and microfossils in the same city in Nagpur when we were in the Tuli International that time. We are having a micropaleontology colloquium. See here, the Mother Earth is in tears. See, the Mother Earth have the life because of the protective umbrella of the greenhouse gases. Because there are greenhouse gases, we all are here. But excess of anything or everything is bad. And basically it is the petroleum and the coal is the only cause for the climate change. Then there should not have been any climate change on the earth just say 100 years before. Okay, but as a student of geology, which most of you are, we know the climate has kept fluctuating all the time. So that time nobody was driving a car or pumping carbon dioxide into the climate. So how it was happening? Where there is a natural climatic variability. It's not that only now the climate is changing. Geology students know climate has changed throughout the time. But to see that because of the global warming, with reference to the marine environment, there is an accelerated rise in sea level, changes in the monsoon pattern, there is an increase in the intensity and frequency of the storms, and the fisheries. These are the things which are going to be affected by the global warming. As I told you, if the climate was also fluctuating when greenhouse gases was not there, it means there is a natural climatic variability. Unless we know that, we cannot correctly assess the impact of the anthropogenic changes. And that is precisely the reason we have to study the paleoclimate. And to study the past climate, any geological tool can be used. Since I am a student of paleontology, therefore I am using the marine sediment, and the tool is the microfossil called foraminifera. How from marine sediments we reconstruct the past climate? We see, if you see, if this is the land and this is the sea, the sediment comes to the sea either by river or by wind. Along with them, there are a lot of microfossils living. Now, these microfossils, when they live in the water column, they incorporate all the climate of that time, all the environmental parameter of that time. And after their death, they are getting deposited at the bottom of the sea year by year, layer by layer. So if you take your ship there and take a core and study this layered sediment, you can get an idea how climate has changed in the past. You can put a dating, whether radiocarbon dated or depending upon which time frame you are interested. So you can say when sea level was higher, when sea level was lower, when monsoon was higher, when monsoon was poor. All that things you can study through the study of the marine layered sediment at the bottom of the sea. Now, this sediment has to be studied through some other tool, that is the microfossil. This is one of them, is foraminifera. They are less than a millimeter in size, extremely sensitive to the climate change. Slight change in the environment brings a lot of change into the species composition. There are 40,000 species living into the sea. They are very extremely sensitive. They are planktonic as well as benthic. You can see that those who have not seen forum before, the left-hand side is the benthic foraminifera, which lives at the bottom of the sea, and right side is the planktonic foraminifera. And they're really, if you see in the microscope, they're really beautiful ornamentation. And Chinese are using this ornamentation to design many of the things. These are the things. A full park has been developed in China, which is inaugurated by none other than the President of China. In Nanjing provinces, there are jewelries designed based on the foraminifera. Because of their sensitivity, they are exclusively marine organisms. Remember this, they are exclusively marine organisms. And because of their sensitivity to the climate change, they have been used for the variety of applications like paleoclimate, sediment transport, which is one of the engineering application, petroleum exploration. This is the age-old application taught to all MSc students. But monsoon variation, fisheries changes, paleo tsunami, sea level changes, marine archaeology and pollution, depending upon the time, I will pick some of this application, how you can use the microfossils to the applied aspects. The very first thing is the monsoon, because this is the most important phenomena for us, because they govern the agriculture and which feeds the economy. We quickly use the river mouth microenvironment because salinity indicator species identification lead to the monsoon reconstruction. So you can see here, this reconstruction of last 5,000 years tell us that the monsoon was bigger or better about 4,000 to 5,000 years back. Around 2,000 years back, it was a very bad condition. And still you can use it, the cyclicity in monsoon, which is about 77-year cyclicity. Because we work in a high resolution area, we got the cycle, and the cycle is sub-Milankovitch. Madam Rawat this morning talked about Milankovitch cycle, but there are other cycles as well, the sub-Milankovitch cycle. This is the Glasberg solar cycle, which is basically the radius of the sun which is changing. And it emits more energy or less energy, accordingly the monsoon on earth is changing. And when you, after knowing this cycle, if you see the record, you get an idea that the 77 year is reflected in rainfall record data. And when you extrapolate, you get an idea. When we predict by extrapolating, we know that monsoon is going to be better. We talked this in Pune in 2000, and the years showed that our approach was correct. And the modelers also say, because of the global warming, India is going to receive more rainfall. It means in the future, probably we are going to have a problem with the flood management more than the drought management. Now see here, we started with the 1 millimeter microfossils, and we are talking about the rainfall, which is the atmospheric phenomenon. This is something with a point which I put it. This approach need to be followed in other areas by many more river mouths so that we can get a better idea and integrate this result with the meteorological record to develop the futuristic model. Tsunami is another phenomena which is happening. We all remember 2004 or 2005 tsunami. We Indians are very fond of the foreign experts. We always go with them. When on the East Coast tsunami happened, we invited the Taj Murthy, who delivered the lecture starting from INSA to all the universities. He came to NIO also. Now see what he predicted there. A second tsunami could hit India in the November this year, but this time the killer wave could strike the Mumbai and Gujarat coastline. This was published in September 2005. We all know that this has not happened. Where he went wrong? Because he tried to conclude this based on the past tsunami record, historical records, which is documented just for last 60 to 70 years, based on that. No, if you want to go for climatic prediction, you have to increase your records. If you want to increase the record, you have to go for a proxy. And such proxy can be the foraminifera. We did that work. It is at the near Jakhau area, which was recently again in the news. See, these are the cores. We were working for Sanghi Cement Factory for developing a harbor. And then we collected the samples, core sample. See, here we get an inverted sequence here. And this sequence have a fossils also. Means normally in paleoclimate, this is all geology students, sediment at the bottom is older and at the top it is younger. But here if you see, the younger sediment is at the bottom and older sediment at the top. It is possible only if something is eroded from one area layer by layer and deposited in another area, then only it is possible. This is possible under the tsunami condition. So by this way we can generate, so here in Gujarat area, something around 8,000 years back, a big tsunami evidence is there. So this is the movement is from the deeper region to the shallower region. Now where we can study, which area will get a record about past tsunami. See, tsunami normally associated with the earthquake. Okay, and since it is a earthquake cannot be predicted, it is told the tsunami cannot be predicted. As I told you, Taj Murthy used the record for 60 years. Here is a method by which we can generate the record for past tsunami and see if there is any pattern, and if there is a pattern can be predicted. See here, this is a coastal lake and normal sediment is depositing. Now this normal sediment in lake will not contain foraminifera, because they are exclusively marine organisms. Now, if a tsunami comes, now a layer will be deposited. Now, this will contain marine sediment, marine organisms. Again, the normal sequence is there, and again, second tsunami, you take a sediment. So, if you see study, no forums and forum and no forums, put a date, you get an idea when tsunami happened in this area, and generate a record, apply statistics, if possible, extrapolate. There are two such areas. This is for those students who want to have a future career. These are the two areas which are potential areas to study or generate the past tsunami records. Now, this is one of the things which very much concerned with the today's gathering, the sea level changes. If you see, the sea level is not a constant phenomenon. I remember in my school book, it was told, समुद्र अपनी मर्यादा नहीं तोड़ता. ऐसा सच नहीं है. इसी चेन्नई में बैठ के प्रधानमंत्री जी ने कविता लिखी थी, उन्होंने भी यही कहा था कि समुद्र ने अपनी मर्यादाएं नहीं लांघी, लेकिन जियोलॉजिस्ट जानते हैं ऐसा हुआ है, और बार बार हुआ है, और हर जगह हुआ है, और हर समय में हुआ है. So there are many times the sea level was up higher than present and lower than the present. But if you see the reference, all are by the foreigners. From Indian region, see, we cannot apply what others have done because it is a relative sea level records. From India, the sea level studies started by two people. One is R.R. Nair from NIO, and another is sitting here, Dr. Vishwas Kalle and Rajguru, who published a paper long back. But that time, very little record was available. We have updated that curve little later. But how to do that? See, first you need to know when sea level was higher than today, which is likely to happen now because of the global warming. See, these records, they are in the Goa, the depositional environment, and these are the erosional features. So sea level was higher sometime here and left this signature. Now, we have summarized these records, and you can see that around 15,000 years back, sea level was higher, about 100 meter lower than today. Visjit, you were asking the question how much sea level will go up and something. We already estimated this for west and east coast of India with reference to our sea level project. I will let you know some other time. Around 9.5 thousand years back, it was between 30 to 40 meter. Around 7,000 years, it has crossed the present limit. Around 6,000 years, it was higher than today. Around 3.5 thousand years, it was lower than today. And then around 2,200 years, it was higher than today. So this is the sea level record. See, this is another method how to get an idea when sea level was lower than today. If sea level was here, and this is a small hillock is there, or pinnacle, and if sea level is rising, now you can put the date, you can take the carbonate from here and here, so and you put the date. So depth versus date, if you plot, you get a sea level record. Now this past sea level records tell you what happened in past, how it has affected the mankind for which we all are worried now. We will finish it first. It is having an implication in the marine archaeology, or some of the very famous monumental areas in India, starting with the Lothal. Some of you might have seen this in Gujarat nearest Lothal. Lothal is about 12 kilometers away from sea, few meters above the present sea level. 1954 it was excavated, and they found along with many other seals or artifacts, a big tank-like body. Now this was a controversial problem. Some says it was a dockyard and some says it was an irrigation tank. 40 years, 45 years this controversy was on. And when we came to know, this shows the need for a integrated studies where all branches of science should come together. Archaeologists were arguing with archaeologists, that's why controversy was on. And but we found that the foraminifera in this tank-like body, and this has proved that it was a dockyard. And friends, this is very proud thing for us. We are now, this is the world's oldest dockyard, 4,500 year old, which is ever discovered in the world. And now the government of India is building a 300-acre marine heritage museum there. It's already under construction. Another thing is this is NIO's flagship program for Marine Archaeology Division about the submerged Dwarika. There was a lot of debate why Krishna's Dwarika was submerged. I will tell you why it is submerged. But these are the remnants of the ancient city, which is about 6 to 8 meter water depth now. This is another very important archaeological finding. It's about Dhalavira. Recently, it has been discovered by UNESCO as a World Heritage. See, so far, Dhalavira was world famous for its excellent water conservation system. But we found, if you see here, this is map, the citadel area and the outside wall. the citadel area has been encircled by 18-meter thick wall. 18 meter. Even China wall is not that thick. Kumbhalgarh wall, some other time I will discuss in detail, but according to us, this wall was built to protect themselves from the tsunami. Because this is on Makran coast, which is a tsunami prone area. Already 8,000 years back, we reported a tsunami from this area. So they knew that this is a tsunami prone area and they built the wall to protect themselves. This is 18-meter thick wall. This is another very controversial problem. Those who are from Government of India and related with climate change or geology, they have been repeatedly asked to answer this question. Whether Ram Setu was a real or imaginary, it's a big controversy, and its age through the planetarium software is given about 5,100 year BC, means roughly 7,000 year BC. Why I am showing you all this to you? Because all these things explained by the sea level fluctuations. If sea level keep fluctuating, what happens here? See here. Ram Setu, 7,000 year. If you see here, sea level was about 3 meters lower than today. And if you see the water depth is about 10 feet there, 3 meters. So that time, sea level was lower. It was a shallow patches in between. It was possible to build a causeway. Okay, it's not a flyover Setu. It is the causeway Setu Bandh Rameshwaram. It was a bandh. Now, so it is possible. It is not an imaginary thing. Then you see here the Lothal. I told you, Lothal is on land. Many people were telling how it is possible to have an ancient dock on the land. Sea level was higher here. When sea level was higher, it was connected to the sea. And therefore, we had the Dwarika. Dwarka is here. When sea level was lower, that time Dwarka was built on a reclaimed land. And when sea level has gone up, it became under the sea. Here is another very important discovery by National Institute of Ocean Technology from Chennai. It also became a very controversial. India today brought out a special issue. Outlook also brought out a counter issue that it is all hoax. It is not possible to have an ancient city. But friends, if you see here, between about 9.5 thousand years back, sea level was 30 to 40 meters lower than today. So it was possible to have a city there. Till today, nobody can name this city. But yes, there are evidences. With Hema only I have gone to the NIOT and seen the artifacts which they have recovered from this site. So friends, if no preventive measure has been taken now, the tomorrow's archaeologists will start feasting on the modern day cities. Like the present day archaeologists are feasting on the Dwarika. It was a flourishing city 3,500 years back. Now it is an object for the archaeologists. If we don't take care, think about it, all our coastal cities, what will happen and who will be enjoying on that? Now this is the last 2 slides I put it. Foraminifera are also useful to see the marine pollution. There are many methods, chemical and other biological, but when these methods fail, we can take the help from microfossils and they give a better result and a cheap, with the less money expenditure. Wherever any industrial waste is there into the sea, including the oil pollution, we get these abnormalities in foraminifera. And when first time when we published this result, we were told, look guys, you are going to a known polluted area, collecting forum, found some abnormals, and you say it is because of the pollution, maybe because of other factors. To counter that and to satisfy that need, we started the culture program. See, ours is the only laboratory in entire Asia now which is culturing these microfossils to develop the new technique for paleoclimatic reconstruction as well as for the pollution monitoring. This was the parent foraminifera. It is reproducing in the lab, and this is small babies which are going out. We are picking them, putting them into the control environment. We put a control experiment like biologists, then go on adding mercury or arsenic, whatever pollution you want to study, and see the difference. So you can see here, and whatever today I am talked, it is all supported by the published records. If you want, I can give you reference for each and every conclusion which I have reported here. Now you can see this is a without mercury in the media, and this is an abnormal specimen so foraminifera can also be used in marine pollution as well. This is all about application. Recently, the reconstruction of past climate based more on the instrumental analysis like calcium magnesium ratio, oxygen isotope ratio, other isotope ratio, and with the development into the mass spectrometer, there is a tendency to use only one or two specimens for isotopic studies. How that? For that, you should know that if you are using one specimen, this specimen representing which month? Okay. Now here, earlier studies were telling the sediment trap data, it is we deployed with the German collaboration. See, this is a record published by Americans. They say the life of planktonic foraminifera is the order of weeks. If it is the order of weeks, then throughout the year we should get the dead test at the bottom. But here, you can notice here long gap, 6 months gap, and they are becoming more into the sediment traps whenever the food supply is more during the upwelling. So it means we propose that the age of foraminifera is not the order of week, but it is the order of months. It is at least 6 months, and if this is true, friends, you can question all those reconstruction of past climate which is done based on the mass spectrometer. Next time when you are sitting in any gathering and somebody is presenting the isotopic data, ask them, what is the age of planktonic forams? So this was a small step to unravel the past in order to illuminate the future. Thank you very much.
Open for questions.
So we can thank you.
Yeah. Okay, if no questions.
Sure.
Yeah.
Discussing with my team over here, there are people who are from the laboratory biostrat, doing biostrat. A lot of interesting things, and of course, I have been to Dholabira, and my sort of a hobby is reading history.
Okay.
So we were just discussing about Lothal and all, and I've done field in Bhuj area for 15 days, been in the areas of Sar Creek and Kori Creek. So
Okay.
I could well relate what you were talking about. And incidentally, a couple of world-renowned paleontologists of their time, Dr. D.S.N. Raju, if you've
Yes.
heard about him.
I know him.
And then Dr. Govindan.
Yes.
Just, I think, 2 months back, I met him in Chennai. He was my senior when I was posted at Madras. So I've done the Trichinapalli area also, the Cretaceous of Trichinapalli field. It's very interesting, and I was just telling them and asking them how much they know about it. So a lot of, queries, and of course the way you're putting it, because of course tsunami does get related to the earthquake and the plate tectonics or the stress build-up. So it's quite intriguing.
If you just permit me a
Sure, sir.
minute
Sure,
reply,
sure,
I
sure.
will
Please,
just give-
please go ahead.
I will just add to it. Since you had been to that area, and Govindan and S.N. Raju, they used to participate in paleontology colloque. Even Sudhir Shukla is a paleontologist.
And, even Dr. S.K. Biswas.
Biswas.
Yeah, so I've been to the
Particularly
field.
Dholavira, the big question was whether tsunamis, whether they could protect themselves from the tsunami after building the wall or not. So what we did the GPR survey in the lower town area. Okay. There we found 3 meter thick sediments, 3 meter without layer. See, normally whether river sediment or lake sediment
Yeah,
or
you would
sea,
get,
they have a
yes.
layer.
Yes.
This is possible if you bring a 1 truckload from somewhere and dump it.
Yeah.
So it was one-time deposit. So question was there from where the sediment came. From either from the river or from the seaside. It is already water-starved area. Okay, and if it is from the river, it should not contain foraminifera.
Yes.
So with the permission from Archaeological Survey of India, which was the most difficult job in the world, I have to threaten them to get the permission. I asked them, I want to, after the GPR survey, I want to have a trench. They said, you cannot do it. I said, why? Well, it is an active area. I said, but we have certain idea, we'll cover it. बोले नहीं साहब परमिशन तो नहीं मिलेगी. So then I asked them, if without permission if I come, what you will do? They say, we'll call police and arrest you. I said, you call the police, I am coming with the journalist. 20 साल से आपने भी काम नहीं किया और हमें भी नहीं करने दे रहे. So then I got the permission. When I did the thing, they got foraminifera. It means tsunami was able to break the 7-meter wall and entered into the Dholavira area. So tsunami could be one of the reasons for destroying this ancient town.
Yeah.
But one question remained to be answered, whether this tsunami could also cross the citadel, the VVIP area. For that we have to do a GPR survey and trenching within the citadel. By the time I got retired from there. So future any archaeologist or geologist want to have it, do that work. It's hardly required some 1 week work. And your paper will be accepted by any journal. That is a wonderful future topic. BSIP people, आप लोग करिए. Okay, so this microfossils is, I will give you a statement by the Tad Murthy. He says, if I get another chance to live, I will become a paleontologist. Though he was a geochemist, geophysicist. Thank you. If any more questions, then it's more.
Respect to, in continuation of this, sometime, actually myself Rakesh Bora, some ONGC. So in continuation of this, in the subsurface, suppose in 500 meter or up to 1 kilometer, we have seen some mass transport type deposits. Mass transport complex type deposits. There, sometimes we had the paleontological data, but due to this reworking features, we are unable to use or to predict exactly what we want to the environment. So, are there any method to overcome this rework fossils or to master complex?
Rework fossil, we encountered, we have published a paper also on that. There are 2 things. Relict foraminifera and reworked foraminifera. Relict are the one which is at some place and they remain there, but they could not be covered by the sediment. Okay, which is along about 60-meter water depth. There is a relict sand zone which is full of oolites. And Kale is sitting here, he can tell you the relict, this oolites tells that sea level was lower than today. So that is relict. What you are telling is the rework foraminifera. We got it off Narmada and Tapti river. There is a Miocene exposure near Narmada and Tapti. Narmada Tapti and Kim River complex. Now these rivers eroded these sediments. They are sediment filled. Now, so they are now no more a shell. They became something like a small rock type thing with the impression. And when they are transported, they are very polished, very difficult to identify. Only you can say this is foraminifera. So if they are filled with the sediment, and if they have a transportation history, you can tell that these are the river foraminifera. There is another thing which people encounter is the slumping. Because many times in course, ONGC course we have seen, there are the slump material comes. Even PRL, if somebody is sitting here, PRL people, they were working. When we have seen those sediments, we told don't work on this course because these are all slump material. Why? How we could say it just by seeing in microscope. There are certain species which will live only in the shallow water area. And as such, you are getting them into 60, 70, 80 meter water depth. This is not possible. They are not fossil, they are recent one. So if you, many times people ask the question, you are telling about tsunami sediment, river sediment, wind blown sediment. So there are methods by which with the experience you can say that these sediments are in situ deposit or they are transported from anywhere.
Well, it's a very interesting topic, and I'm sure there will be a lot of questions. And since the time is not there, I think we request from the organizers if they want us to break now for the lunch or no. Can you make an announcement then? Because we still have 4 papers on our agenda.
We had 2 excellent keynote addresses actually, and like very enthralled, but no one likes the food to be served late and that too cold. So let's have some hot, warm food, and then we break for lunch with the permission of chairpersons, and we again resume this very interesting session. Thank you.